Hello everyone, let's look at this integral here. This integral has a cosine square of x. And to integrate this function, we cannot really use u sub like we usually do with an odd power of sine or cosine. So what we need to do is that one way is that we can use the half angle formula to convert this expression into something that's linear in cosine, so that we can integrate directly. Another way is to use integration by parts. I will actually do another video on that, but for now, we are going to use just the half angle formula to integrate this function. Okay, so let's try this. First, I'm going to recall. Okay, so I'm just going to recall that the half angle formula. What I'm going to write down here is not really the half angle formula that you usually will see in your trig textbook. I'm just going to write a form that's in that looks different, which is still the same formula, but it's going to look different from the one that you usually will see. So this is more like a variation of that formula. Okay, so what happened is that if we have cosine square of x, okay, so that's what? That's equal to 1 over 2 times 1 plus cosine of 2x. And then now what happens right here is that this x right here, this is x, right? So let me just highlight that. And so if you have x right here, so the angle is x, then what happens? We are going to have 2x right here. So this angle is double of that angle. Or we can say that this angle is half of this angle that you have on the right hand side of the equation. And so we can say that this is half of that, so that's also the half angle formula. In the usual textbook, you're going to get the square root right here with the plus or minus sign in front of it. And then also you are going to have theta over 2 right here, and then there's the theta right here. So that's why I said this is more like a variation. This one looks different, but this one is more convenient for solving this kind of problem. So that's why I'm writing down this one. Okay, so now let's get started. So first, we are going to rewrite this integrand using this formula right here. So we are getting what? The integral of 1 over 2 times the 1 plus cosine of 2x. Okay, so 2 and then the x. So I'm just making that substitution right here. Oh, actually, let me just put it back in the different color. Okay, yeah. So that's that. Okay, so as you can see here, cosine square x, that's the same thing, right? So we can replace cosine square x with this, the right-hand side. Okay, so as you can see here, the 1/2 is a constant, right? So to integrate this function right here, we do not need to worry about this 1/2. We can actually take it outside the integral so that we don't need to worry about it until the end. So here we are going to get the 1 over 2 integral, 1 over 2 times the integral. We have 1 plus cosine of 2x. And now there are two terms in here, and we can integrate both of them directly without having to use any special techniques. And so let's do that. So integrating the 1, that will actually be pretty easy, right? We are just going to get x because we are integrating with respect to x. And then we are going to integrate the cosine of 2x with respect to x. For that one, we need to reverse the chain rule because there is the coefficient other than the 1 in front of the x. So the antiderivative for cosine is going to be the sine. So add the sine, right? Add the sine. And then now, just to write down something right here. So you know that inside the sine function, we have 2x right here, right? We have 2x right here. So what we are going to do is that we are going to actually, instead of highlighting the x, I should just highlight the 2 because that's what we need to worry about here. So we need to multiply by the reciprocal of this 2, which is what? Which is actually 1 over 2. Okay. And then we also have the constant of integration. And then just one last step, we can distribute the 1/2 on the outside just to multiply to those two things. So we are going to get what? We have 1 over 2x plus Then we have the 1/2 times the 1/2. We are going to get 1/4. And then we have sine of 2x. And then plus c. And then we're finished. So this is the antiderivative for the cosine square x. Okay. So if you want to see an integral with an odd power for the sine and the cosine, you can see the link in the description of this video. And for that one, you only need to do a u-sub. But for this one, when you have just even power for both sine and cosine, and then you would have to use the half angle formula. Or another way to do it is to try integration by parts, because that can be written as a product. Okay, so that's it for this problem. If you like my video, please check out my other videos and subscribe to my channel. Leave me a comment, give me a like. Thank you for watching this